The topic of the course that we are going to cover will be, I'll shortly introduce. The course is on object-oriented system design, and it will be taught by me, Professor A.K. Mujumdar, and my colleague Dr. Sudeshna Sarkar. And the topics that will be covered are as follows. First, today I will discuss to give a brief introduction on object-oriented, basically on objects and object-oriented methodologies, and the key concepts about the objects. Then we'll go on detail. I will discuss in detail about the object modeling techniques and the inherent concepts about the object-oriented methodology. So we'll cover then classes and objects. Among the object modeling, we'll cover both static and the dynamic models. In the case of static models, we'll see that the static model will be described by the attributes of an object, messages and methods, and how objects can communicate with each other with the help of messages and methods. Then we'll discuss about how different objects can be interrelated to each other, and with the help of such an object relationships, we'll discuss the different types of object relationships, and the different types of relationships that will be used or discussed will be generalization and specialization, how a hierarchy of classes can be constructed, and how a subclass can inherit properties from the superclass. Then we'll discuss about the concept of aggregation, which is used to construct composite objects, and how hierarchy of aggregation, the objects which are formed by a aggregation hierarchy, will be discussed next. The concept of grouping of the objects will be another new type of relationships that will be discussed next. Continuing with the object modeling, we'll discuss the concept of polymorphism and operator overloading, the abstract class, and the dynamic modeling. Then, in connection with the dynamic modeling, we'll discuss the concept of states and events. Followed by, after introducing these basic concepts about the object modeling and how the objects are interrelated to each other, we will look at the object-oriented languages and what are the key features of an object-oriented language are. In this connection, the course will focus mostly on Java, although there are other object-oriented languages like C++ or Smalltalk, etc. So, to begin with, we will first introduce basic operators and data types in Java, as well as the control statements in Java. You will see that some of the control statements and the types and operators are very much similar to C, and which you are already familiar with, and only the differences will be highlighted. Then once we have introduced basic concepts in Java, basic data types and control statements in Java, we'll look at how the Java objects and classes are defined, how the instances can be created with the help of constructors, and how Java methods can be defined with respect with each class. The concept of object lifecycle and inheritance between the subclass and the subclass from superclass also will be described in detail. Following the Java language features, then we'll look at the concept of Java abstract class, how access control is enforced in Java, because Java provides a rigid access control features which helps in encapsulating the objects. The Java packages and interface will be discussed, and followed by the exception handling in Java. So with this, we'll have a very good exposure to the Java language and how it can be used in modeling and representing objects. And after that, my colleague Dr. Sarkar will look into the object-oriented modeling and design using object modeling technique called OMT. She will discuss the structural modeling, dynamic modeling, as well as the functional modeling aspects. After that, we will look into the UML language and basic structural modeling, classes, relationships, class diagram, and advanced features. So you will have an idea that we have Java before and then UML, and how both these languages can be used to create an object-oriented environment. In UML, it is also possible to define basic behavioral modeling like interactions, use cases, use case diagrams, interaction diagrams, and activity diagrams. And UML will be used to describe the architectural modeling and implementation diagrams, and advanced behavioral modeling, that is looking at the dynamic models of objects, that state machines and state chart diagrams. And with this, now we have a very good exposure of the two different languages which can be used for object-oriented modeling and design of the object-oriented systems. Next, we'll look into the client-server computing, and in this respect, we'll look at how the client and server communicate, and using the message passing and the remote procedure calls. This will be for this up to this point. This will be covered by Dr. Sarkar. Thereafter, since we have already introduced Java language, we will now look into how Java can be used to support client-server computing. In this respect, I'll first introduce the concept of Java threads and how multiple threads can be executed and can be synchronized. This enables us to create multiple threads so that we can do certain jobs almost concurrently. And then we'll introduce the concept of Java sockets and how Java sockets can be used to implement client-server computing. In this respect, we'll both look at connectionless and connection-oriented protocols. And finally, I'll look into the Java applets, which is now very much has become very useful in internet programming and has tremendous applications. So this exposes you to the Java and its usage to the client-server computing environment using an object-oriented approach. Next, Dr. Sarkar will look into the standards. There are several standards have been introduced, and mainly among them two are CORBA and the COM-DCOM by Microsoft. The CORBA is called Common Object Request Broker Architecture. So he will introduce this architecture, and then concept of object request broker, the intermediate description language, that's ideal, object adapter, and CORBA programming with Java. Followed by this, we will discuss the Microsoft concept of COM and distributed COM, where the objects, components, interfaces, and basic programming architecture will be discussed. Remote architecture and where protocol architecture will be used. So with this course now, you will have a basic idea of the object-oriented design and how even in a distributed environment, the objects can be used and how they can be combined together to create a complex object-oriented system. The books recommended for this course there are several ones. Among them, the Grady Boch book. This is probably one of the most frequently cited book in object-oriented design by Benjamin Cummings. There's a book by Ramberg, Blah, and Premerlin, Eddy, and Lorenzen on object-oriented modeling and design. Then there is a book by Witz, Brock, and Wilkerson and Weiner on design of object-oriented software. These are all on object-oriented design. Then we have a book by Barton Bartran Mayer, which is a very well-known book on object-oriented software construction, and it gives you the very good flavor on what is the basic concepts in object-oriented programming environment. And then will cover the initial part of the course, as well as some of the later part. Then on Java, although there are several books in the market, we will look into, we can, like, in fact in my talk on the Java introduction, we will mainly refer to three books, one by Patrick Norton and Harvard Shedd on Java, the complete Java reference manual by McGraw-Hill, which is a 1997 publication. Then Mary Campione and Kathy Walrath, the Java tutorial, it's an Addis University publication in 1998. And last and but not the least, that is the most important one, the designers of Java, the book, The Java Programming Language by Addis University by Ken Arnold and James Gosling. So these are part on the books on Java and the introduction to the object-oriented systems. On UML, the books will be Grady Butch, James Ramberg, Ivar Jacobson, The Unified Modeling Language User Guide by Addis University. It has an international student edition, 1999. On Corba, we'll refer to two books, one by Sean Baker on Corba distributed objects using Ortex, ACM Press publication. ACM Press book is an Addis University publication in 1997. And then there is the Jeremy Rosenbarger Teach Yourself Corba in 14 Days. That is a Tech Media 1998 publication. On COM again, there are quite a few books, some of which are by the two books which we will be referring are by Tuan L. Thai on Learning DCOM, O'Reilly on 1999, and Dalton Box Essential COM on Addis University Longman 99 publication. So you see that it will be almost a very large, the coverage of the course will be quite large, and some of the books can be used as a reference only. It's not, and we hope that the course will give a complete coverage on some of the topics I have mentioned. To begin with, therefore, I'll concentrate today on the introduction part, and to do that, let's start with the very basic idea of that how normally we do the software development today, and what are the different techniques, and one of which, the most commonly used techniques as on used today, aside from the object-oriented one, which is called the functional approach, or sometimes called the process-oriented approach. If you look at the process-oriented approach or functional approach, what happens? We have a data and a set of functions which operate on the data. Examples might be, say, data you have a, say, array of records, which you have done in your earlier courses, or a file, and the operations that you can perform on this data are find maximum, find minimum, search. You can sort them, bubble sort, using bubble sort, quick sort, heap sort. So what happened? The data and functions are in a sense two separate things. The functions operate on the data, and many of our classical programming languages like C or say Fortran or even Pascal, you have seen that in the function declarations, when we declare a function, the function can have some global data as well as the local data. So for example, when we declare a function in C, say int f, we can say this is a float b, and say int c, and here we can have some local function, say int a. Now inside it you have a code, so you have the local data and then some of the data which is passed as a parameters b and c to the function f, and this function performs certain operations, and it may also refer to some global data. Similarly, we can have another function, say int, so let's make it char g with some parameters followed by the codes. So what happened in a functional approach to the design? Normally, we identify certain operations that are the functions that will be used to solve the problem. So basically, we say that this is a how oriented approach. So given a complex problem, we try to normally we use an approach called modular decomposition, in which the approach is that in a modular decomposition approach, you first decompose a complex problem into smaller tasks or modules, and some of which may be the functions itself. And these functions they are being called in using the programming language constructs whenever they're necessary, and to solve the complex descriptions. In this problem, and in this respect, the very common approach, which is called the hierarchical design approach, in which you decompose the problem in a top-down manner, and then the top-down design, like say for instance, you have a complex problem, you can say that this problem will involve solving these three BCD problem in sequence, and out of which the problem B will involve repeated solving of this problem ENF until certain conditions holds. So we write it repeat until, and whereas this problem can be solved if either this and this under certain conditions is executed. So what is happening? Therefore, a complex problem is solved by decomposing the smaller problems into smaller problems which are manageable, and some of these problems are essentially implemented with the help of functions, and which are called as and when required. So for example, it might be a function E and function F, which will be repeatedly called until certain conditions is satisfied to solve the problem B. Similarly, the problem D will require solving either G or H depending on the conditions, and these will involve solving these problems in sequences. Now this kind of approach is very popular and probably one of the most commonly used technique. It has its advantages, that is, it somewhere or other is an algorithmic one. It's a direct correspondence with our idea of the algorithms, and also has appealing, and there are many tools available today to express a complex problem, decompose it in terms of smaller ones. We have so-called case tools. So, however, there are certain problems also in this kind of environment. The problems might be that suppose you have the different modules now for the functions, and if I make a certain changes in one of the functions, say for instance in F, and it may so happen that say for example I may change the type here B float to something else, it requires a different more general parameters. Then while calling it or the code, then when it is called, unless there is a proper matching of the types between the calling the parameter that are being passed to the function and the formal and the actual parameters, then we have an error will occur. Similarly, when the data value of the function returns, if the type mismatch occurs, we will have a problem. Again, changing of the code may have a rippling effect on the entire program, and it may be often difficult to handle. Again, although hierarchical structures or the modular structure is very useful, look at it, but sometimes it is very difficult to enforce, in the sense that, for example, some of these modules require initialization before they can be executed, and in this case we must have an initialized module which will interact with all or some of these modules to begin with, and therefore the hierarchical structures the structure description is violated in that sense, and if you are not properly initialized, the error will occur. Now, as opposed, and secondly, there is another feature that one has to look at. Another approach of the modular decomposition is that one has to introduce certain protection mechanisms, that the modules should be properly protected, in the sense that some unauthorized access to the module code is not permitted, and that's where the concept of encapsulation came in. And the third one is that this modular app decomposition approach, that once you have several modules, that we should be able to combine them. And one of the classical examples of this is in the case of an Unix shell programming. We have several shell commands which are piped, and we are basically combining them in a modular. We are combining each of them being implemented as a module. If you think of, then we are combining them together. So when we define in terms of modules, we have the modules can be defined in the form of, while doing a top-down approach, we should be able to introduce certain encapsulation. We should be able to combine them together, and the problems I just mentioned, sometimes although this is advantageous, it may create a problem have a problem of its own, in the sense that changes in one module may have a rippling effect on other modules when solving a complex problem. As opposed to this, in an object-oriented design or object-oriented programming, what we do, we look at the problem in a different way, slightly different manner. If you look at the first class, that is a functional approach, here the emphasis is on the functions. It's the functions you can think of as the first class elements. So it is the functions which operate on the data. On the contrary, what we do in an object-oriented approach, we say that data is more important in the sense that each data, along with data, we associate certain operations with it. So these constitute an abstract concept of abstract data type, which you can think it of as a precursor to the object-oriented approach or object-oriented programming in that sense. And so we have a data like, say, and it is very intuitive. If you think about the classical programming also, when we talk about integer, int in C, we know automatically there are certain operations you can perform on int, and which are and, say, so add, subtract, multiplication, integer division. Similarly, you can have, I have a more complex one, say the matrices. Say we can have a matrix, say x 2 3 of type integer, and say y is also another integer data of the similar dimension. Now in normal programming and languages, operations directly on the matrices are not permitted. However, this kind of, that is a simple assignment, is often permitted. So we can think it of assignment is also an operation in which y data, if you have read the values of y, you can assign it to x. Again, we can write our own functions in C to perform addition of matrices, multiplication of matrices. However, in an object-oriented environment, what we'll look at matrix or array as an abstract data type or abstract class. You can think of it as a class in which certain operations are built in. These operations, you can use them, which is the terminology sometimes called the Maximus methods. You can perform them, or you can call them or use them as and when required. So as opposed to the classical design, when you are solving the complex problem in terms of the interconnections of the smaller modules, we can think it of as object-oriented design. We can think it of, we have several objects, say this is object A, we have object B. Each of these objects are capable of performing certain operations. And what we can do, we can design the software such that whenever necessary, object A, an instance of an object A can send a message to object B, which in turn can send a message to object C to perform certain operations, which is defined in class in the C class. So the style in an object-oriented approach is that we focus mostly on the data, where data is not like a simple integer where we just a storage of information, but along with the data we can think it of, it has the capability. You also allow certain way you also define how this data can be operated upon. So the concept of functions and data, you can think it of an object to be integrated together, which will be of use. For example, in case of an array of records, we can think of each one of these as a sort of operations which can be performed on array of records. And if I want to find the maximum, we'll call the find max with the array of records. The records may be of array of the characters or integers, or any other data type, or complex records. So the paradigm or the approach in an object-oriented paradigm, the approach is or the importance is given to the objects and their interactions among the objects. So this is briefly the distinction between the classical approach and the object-oriented approach. When the classical approach was, you can think of, sometimes called the process-oriented approach, is the focus is on the functions. What are the functions you want to write, or the modules you want to define, and the programmers are given the job of writing the modules, and ultimately you have to integrate the modules together, and each module or the functions, as we know, has a side effect which will create a problem. Whereas in object-oriented approach, you create the objects, you define each object, you can think of them as a component of an object, of a complex object, and then once you have built up the components, then you integrate all these components in a sense that when the complex object is built, let it communicate with these objects, the component objects will interact with one another to create an environment which will solve for solving the complex problem. So with this brief introduction, let us now look at the basic terminologies that will be used. And naturally, the first question that arises is that when you talk about objects, so we will have to answer the question, what is an object? Is the most important one, and in this respect we can think it of, or is done, an object can be thought of as an abstraction of a real world entity. For instance, if I think, say, if you think of the students, now we can say Mary is a student. Now Mary is a student. Now we can think it of Mary as an instance of is an object which is of type student, and therefore it's an abstraction of a real world entity of student. The student and Mary is an instance of that student class, as will come the concept of class. Similarly, we can have several students. We can have John also as a student. So the real world similarly is also a student. We can have other students also in the class. If we look at the real world entity of books, we can think of there are several books, and we can treat each book as an object. For example, if you think it of Goda, written by Rabindranath Tagore, is a book. Similarly, we have, say, another book which is a book on, so let's say, on databases by Almond. Say, Principles of Database Systems. This is also a book of database systems. So if you look at the question arises, therefore each one of them we are treating in respect. So each book will have certain authors, and we have the title of the book. So we can think it of the book as a real world entity, and each of there are several instances of the books. Example being Goda, or a database system book, or we can have a book on medicine or physiology or history. All of them are books. If you look at other domain, for example, in case of an integer, 3 is an integer, 109 is also an integer. So these are also instances of integers, and we can treat them, each one of them, as an object. So what do we mean? Therefore, an object is an abstraction of a real world entity. And naturally, how do you characterize such an object? So object will be characterized by structure and the behavior, and the structure, each object will have its own inherent identity, and the second one is that each object structure is defined by its attributes and parts. For example, in the case of a student, let us say a student, if you look at the student object, now each student, we know what are the attributes of a student will be the name of the student, the roll number. Normally every student is roll number or registration number, whatever you will say. We can say that each student is registered into certain courses. So courses student is registered into, the subjects taken, and the grade obtained in each subject. In case of a book, these are the attributes of students. So if I look at Mary as a student, so what is essentially we are talking about Mary, the object Mary is the name of the student is Mary. She may have a roll number, say. So the Mary Mary is a student, and so name is Mary. The roll number might be something, say let us say 9917102. Course, she is registered into, say, postgraduate diploma in information technology. Subjects taken, one of the subjects is, say, object oriented design. There are other subjects she is registered into, and so whatever the grade she gets in each of these subjects. So whenever we talk or think of Mary as an object, we think it of all these together, and naturally, as I mentioned just now, each object will have an unique identity or inherent identity. For that, there may be multiple students having the same name. So therefore, the name need not be an unique identity. Similarly, if the student, say for instance, withdraws and later on comes back and registers, roll number may be changed. So therefore, what we can do, we can assign otherwise roll number is normally a unique identifier. However, with each object, what we can say, we will see that there is a unique object identity which remains, which will remain there, which will not be changed during the lifetime of the object. So each object that we create, instance, will have a unique identity. And the object structure is defined by its attributes and the parts. So in case of a student, therefore, we have seen that these are the attributes of the student. In case of a book, what will be the attributes of the books? If you look at the book, the attributes are, we can think it of, the title of the book, authors, there can be multiple authors, or single author or multiple authors. We have a publisher of the book. The book has the year of publication. These are all attributes of a book. Similarly, the price. You can have other attributes of the book. So when we talk about Gora, written by Rabindranath Tagore, so we can think it out. Gora is a title of the book. Author is R.N. Tagore. Then publisher is somebody say Vishwabharati Press. The price and the years might be something. So similarly, we can have the database books by Talman, or or Romeo and Juliet by Shakespeare. Any of them are instances of the books. So what is happening? Therefore, you can see that in this example, at least, each these two, we have the different. The attributes are the in the case of books are these. Now, it is not necessary that the attributes may be of very simple type, in the sense they are all integers or character strings. For example, let us say, that's why we have said that the objects structure can be defined attributes and parts, so the part itself can be an object. For example, if we look at car as an object, now the object car, we know, has several components of the parts, one of which is engine, then it has a chassis, it has its tires, then it has the manufacturer, who is the manufacturer of the car, then the car has the registration, then the registration number, price, and so on. Now you can see some of them may not be very simple type or the simple objects. For example, engine by itself is a very composite object, in the sense that it has several parts or several attributes. For example, with engine, we can say that what is the horsepower of the engine. We can have engine can have a different manufacturer. What is the type of the engine, whether it's a diesel engine or it is a petrol engine, how many cylinders are there, so on. So you can see that it is possible that when we, as we'll later on see, that when we look at objects, it is not necessary that the attributes or the parts of an object may themselves be of the very simple or primitive object. So it will be therefore necessary that how do I, from the very primitive objects, how do I create a more complex objects, and that is where the interrelationships among the objects come into play. The second thing that one has we look at, that when we talk about the objects and the class, say objects having the same structure and the behavior are grouped into a class. Example, when we are talking about the student as a class, now the student, we can think it of as a class. Now if we look at, we can think it of Mary is a student, is an instance of the class student. So student is a class of which there can be several instances. Example, Mary, John, we can have John is a student, we can have another student, say Lena. Similarly, we can have a student called Ashok, and so on. So all of them will be calling are called instances of the class student. So these are instances of, and whereas what we want to emphasize, that each one of them being an instance of a class have the same properties, in the sense they have the name, roll number, course, and subject. Each one of them will be having these attributes. While defining the object's class, so therefore these will be clubbed in a structure called class. So student will be the class and instances are the these things, the Mary, John and Lena. Similarly, in case of a book, we have the book Gora written by Tagore as well as a book by, say, Shakespeare are instances of the class book. Then with each object, as I have mentioned, each object should have a behavior or the operations or the functions in earlier languages to be associated with it. So for example, with the behavior of an object is defined, will be defined by messages and methods which are called operations. For example, in the case of a student class, the attributes are, as I said, then maybe name, address, age, course, subjects taken, grade, etc. And with them, we have the behavior or the operations are the resides in each student, which with this when given to the student, it will return the address of the student. So for example, if we say the resides in Mary, if the current student is Mary, resides in, she may be reside in a hostel, say in IIT called the SN Hall of Residence. Has grade, these are the operations. So given the name student and the subject, we should be able to get the grade, the registered into, which courses he or he is registered into. Other examples of that, say for example, if you think it of the class triangle, which is a geometric object, we know that in a two-dimensional plane, a triangle will be defined by the vertices. So these are the three vertices, x, y and z. Now given the three vertices x and y and z, and we can say the color, each triangle has another attribute called color. Say for example, this is a pink triangle. If I define the color of this is with the pink color. Now what we can do, what are the operations we can perform? The operations will be the draw a triangle. Now when we talk about draw a triangle, we will mean that we draw the triangle given the coordinates. Rotate a triangle. So when we say the rotate this triangle, the examples are the rotate triangle A. So we can say that the rotate the triangle A, or this one, often we can talk in terms of the keyword called this. If we know that we are referring to the current triangle, the instance, then we can rotate it by a certain angle, and for example we might be having the triangle will be rotated so we'll have the triangle like this, so y, x and z. So this will be x, you have rotated it, and this is z. So here you have rotated the triangle anti-clockwise, clockwise, and you have come to this position and by this angle. Similarly, we can also move a triangle. We can move this triangle to another location, say here, and the triangle will become, it will be replica of it when it is moved to a certain distance along a particular orientation. So the methods are to draw a triangle, rotate a triangle, move a triangle. Now when we talk about operations, and each operations, like in the case of a function, as we have seen in earlier function oriented languages like function f, had parameters called float, p and int c. These are called the formal parameters of the function, and when we call them we substitute it with the actual parameters. Here also an operation may have arguments in addition to its target object. The target object means which object, which triangle you are referring to. For example, we say to rotate this triangle, meaning we can rotate this triangle itself to another location, or we can say that rotate the triangle by a certain angle. Similarly, in case of a student, say has grade, the student S in a course and subject B. So when we talk about an operation has grade, that we say that either we can say that if the current student has grade, this will be specified as has grade course C subject B. Meaning when you apply this method to the current student and given the parameters of the course and the subject, it will return the student's grade on this subject which is registered into the course. Say is an undergraduate student in a course on say database systems. Similarly, when we can write this one as a rotate, another version rotate, say angle, where angle is also an object. Say rotate, the angle can be specified by radian or degrees. So we stop here today and continue with the lectures, but continue with this in the next class with our objects and the classes.